Hello and welcome to this Digi session in the power management features included in all the ConnectCore system of modules. In particular today, the Digi ConnectCore 6UL running Digi embedded Yocto images provides superior power management capabilities. I'll be showing you how to set up ConnectCore 6UL SBC Pro board to make the power measurements, how to enable the different power modes, and what the actual power consumption looks like in these modes. The first thing that I would like to show you is how to search the documentation in the Digi website. So if you search for the ConnectCore 6UL, automatically the Digi web page will point you to the landing page for the Digi ConnectCore 6UL system module. If you scroll down under the product support tab, the first link will point you to the documentation portal. So let's click, and from here you will have access to all the documentation related to the ConnectCore 6UL, the software, the hardware, and also some additional documentation. What I'm going to show you today is located under the Digi Embedded Yocto section under the Linux kernel BSP and in power management. So I will show you the numbers in standard running mode, then we will see the standby mode or what is called suspend to memory, and in this mode I would like to remark that this is the fastest low power mode in order to resume and continue doing the application on the CPU. And the last power mode is what is called power off or RTC mode, that will lead into the lowest current consumption, which only updates the RTC on the MCA. The last part of the video will show you how to change some of the boot behavior of the module, and you will find this under the microcontroller assistant and in MCA configuration tool. So I will show you the boot mode, and this will allow you to decide if the module will start as soon as the power arrives, or if in the opposite you would like always to wait for the on-off button to start the system. Okay, so let's start. The first thing that I would like to show you is the ConnectCore 6UL SBC Pro schematics. You can download this material from the Digi website, and this is the board that I'm going to use. As this board was not designed specifically to reach these low power modes, we need to make some changes. So let me show you how the schematics looks like. The first thing that we need to do is to remove this resistor R8, because we don't want to connect our external coin cell or battery into the VCC Li-cell pad. And the second thing that we need to do is to connect the cathode of an external Schottky diode to be connected in this VCC MCA power rail, in order to be sure that once the mains has been completely removed, we will only provide energy from this power into the MCA. So let me show you how to do that in the real board. So the first thing is to locate where R8 is on the board, and you need to look in the bottom side of the CC6UL SBC Pro, and near to the microSD card holder you will find the R8. So you need to remove it or depopulate it. The next thing is to connect our external Schottky diode. So the cathode needs to be connected to this point, which is exactly the same as the two cathodes of the Schottky diode populated on the board. Now you have two options. You can connect only one Schottky diode and in serial your external battery or power supply, which emulate the battery, or if you would like to reuse also the connector, which is on the CC6UL SBC Pro, then you need to connect here also the anode of the Schottky diode. In order to get the lowest numbers in the device tree infrastructure, you need to disable the I/O expander section in order to be optimized at the maximum. Of course, after that, you need to rebuild at least the device tree and populate the new device tree on the board. The setup that I've done together with the CC6UL SBC Pro looks like this diagram. So I'm using a main power supply to power completely the board, connected to in parallel to the power jack. But also I'm using a second power supply which emulates a battery or a coin cell. And in order to show you how the things are happening, I'm connecting two multimeters. One is to measure the voltage, and the second one is to measure the current that the system will draw when we will be on the RTC mode. Good. So now we have all the characters on a scene. So let me show you the terminal. So as you can see, the board has just started the Digi Embedded Yocto 3.0 R2, and now the Linux is running normally. So let's see what is happening on the board. This is the setup. So you can see here the main power supply, and you can see here on the bottom side of the display the voltage and also the current. So you can see that now is drawing 260 something milliamps. This multimeter is measure the voltage of the external coin cell or the external battery, so almost 3 volts, which is normally the typical coin cell. And this multimeter is set up to measure the current that we will see later. I would like to show you also that this is my external Schottky diode. Of course, it's a huge Schottky diode, but it is still valid because it's Schottky. Okay, so the message is try to keep as lowest voltage dropout in the diode in order to save as much energy as possible of your battery or coin cell. Okay. Now I would like to show you how the standby or suspend to RAM is working. I've created a counter script that is just counting endlessly, and the idea is to show you how fast you can go and come back from this standby state. So if I press shortly the on-off button, automatically the system will go to suspend. So you can see now how the script has been frozen, and if I show you the power consumption, you can see that now we are taking only 10 milliamps, okay, comparing with before almost 300 milliamps, that the system is saving a lot of energy. Now, if I press again the on-off button, you can see how the system is waking up in milliseconds, and the software, of course, is continuing in the same point that was stopped. Digi is providing this infrastructure to have several wake up sources. So you can use whatever MCA event and also whatever GPIO on the CPU that you can set up as an interrupt source. The next thing that I would like to show you is how to put the system in power off and to show you the lowest current consumption that you will have when you are entering in the RTC mode. In order to get this, we need to inform the kernel that we would like to shut down. So this will be done by the power off command. And as soon as we see on the screen the confirmation from the kernel that the system was in power down, you can see it now. Let's jump to the hardware world. Okay, so we need to follow the sequence in order to see the minimum current. So the first thing that we need to do is to remove the console, because as you could see on the schematics, there is a USB to serial chip that will add additional current, what we are not interested in measure, and now we can completely shut down the mains power. Once you do this, you can see how the current consumption in the coin cell bus or power rail is around 3 microamps. Okay, so now in order to wake up, again, Digi provides you the infrastructure to use MCA events or GPIOs that can generate the interrupt, or of course, if we connect again the mains, automatically you can see how the current consumption is shutted, because all the system is provided by the main power supply. So let's see what's happened in the console. I forget it to connect it, so let me connect it again. And now Linux has booted again. So if I log in, we can see how the system is again ready to use. The last thing that I would like to show you, because as you could see, the system by default is configured that as soon as the mains power has been received, the Linux is booting. So we can modify that behavior using this command with Digi provide and configure to wait for power key. As soon as we execute it, the MCA will confirm it, and now if I shut down again the board, you can see that here on the LED and also the power consumption, now the system was power off, and if I remove the mains but I put the mains again back, you can see that the LED is not on, and also there is no power consumption because the board is waiting for me to press the on off button, and as soon as I press it, you can see how the sum is starting. You can see now the log and the Linux kernel is booting up again. So that's all from my side. I hope you will enjoy, and please stay tuned for the next videos will come. Thank you very much for your attention.